Hi everyone, I am Shubham and this is my channel. Here you will find the tutorials and end-to-end projects related to the field of data science like machine learning, natural language processing, deep learning or OpenCV. Data science is an important area to have an understanding of in this day. I hope that you will find the content on this channel to be informative and helpful, especially when it comes to jobs and studies. So today we will start with the first project based on natural language processing. In order to move on to the projects, first you should understand what is NLP and why it's important. NLP stands for Natural Language Processing, which is a part of computer science, human language, and artificial intelligence. It is the technology that is used by machines to understand, analyze, manipulate, and interpret human languages. It helps developers to organize knowledge for performing tasks such as translation, automatic summarization, name entity recognition, speech recognition, relation extraction, and topic segmentation. So these are the applications of the NLP. Why is natural language processing is important? So what happens nowadays? Business use massive quantities of unstructured text-heavy data and need a way to efficiently process it. A lot of information created online and stored in the dataset is natural human language. Until recently, business could not effectively analyze this data. This is where natural language processing is useful to analyze those data. So whenever we require to work on the text data and analyze those data, so in that case, basically we use these NLP techniques. Now we move to our problem statement. So our problem statement is fake news classification with the help of natural language processing technique. So whenever we work on the project, we should know what is the problem statement. So our problem statement is fake news classification. So what happened nowadays? Every news that we consume is not a real. If you listen to fake news, it means you are collecting the wrong information from the world, which can affect the society because a person's views or thoughts can change after consuming the fake news. And fake news detection is a hot topic in the field of natural language processing. We consume news through several mediums throughout the day in our daily routine. But sometimes it becomes difficult to decide which one is the fake news and which one is the authentic. Our job is to create a model which predicts whether a given news is real or fake. So this is our problem statement for this project. So this one is the project flow for the projects. So we perform total 8 steps during this project. The first step is problem statement. Second step is data gathering. So here basically we read the data from the CSV file. So once we have the data, then we can go for the data pre-processing. So in that data pre-processing, here we perform some operations on the data like tokenization, lowercase, stopwords removers, lemmatizations, and stemming. So in detail, we will see in the projects. So once we process the data, then our next step is vectorization. So vectorization nothing but we convert our text data into the vectors. So here basically we use two techniques for that. Back of words, which is called as a CountVectorizer also, and TF-IDF, term frequency inverse document frequency. So in our project, we use this TF-IDF techniques. So once our data is converted, text data into the vector, then we go for the model building. So in the model building, we create a one model object. So here basically we use a random forest algorithm to create a model object. And once the model object is created, then we create a train and test model here. So once the model building is done, then we can go for the model evaluation. So we know right now our problem is a classification problem. So we use here the three techniques. First one is accuracy score, second one is confusion matrix, and third one is a classification report. So after that, we directly go to prediction on the client data. But in real world, once we build a model, we need to deploy those model on the AWS or the GCP platform. Now we import the required libraries. So first of all, we require pandas, numpy, as well as regular expression libraries. After that, we require NLTK libraries to perform some operations on the text data. So we import from NLTK dot corpus, import stopwords. This library is used when we perform the removing stopwords operation. At that time, we require this library. So after that, from NLTK dot stem, import porter stemmer and word net lematizer. So these two libraries is required. So basically, the porter stemmer is used to create an object for the stemming, and this word net lematizer is used to create an object for the lemmatization. After that, we require some function from the sklearn also. So from sklearn dot model selection, we require train test split to split our data into the training and testing. After that, from sklearn, we require ensemble import random forest classifier. To create a random forest object, we require these libraries. After that, we use from sklearn dot feature extraction dot text. From this function, we import TF-IDF vectorizer. After that, we require one more libraries to evaluate the model. From sklearn dot matrix, import accuracy score. After that, confusion matrix, and third one is a classification report. So these three metrics we use to evaluate our model. So once we execute this, here we will get the error. Now our required libraries are imported. Now our first tip is data gathering. So in the data gathering step, we read this input file. So we receive the input file in the form of CSV. here news underscore dataset dot csv. So I just copy the file name. So here we create one data frame. So in the pandas, there is one function is there, tt dot read underscore csv. So here we need to pass the file name with the file extension. So our file name is news underscore dataset and extension is .csv. To read the first 5 rows, we use df.head function. So default in this function, the default value is a 5. If you want to read first 10 rows, you can pass number here as a 10. But we keep the default value as a 5. So this is our data set. So there are total 5 columns are available: ID, title, author, text, and label. So once we read the data frame, then we can go to the df.info function. So by using this function, we will get more information related to our data. Like here, we will easily identify how many rows are there. So here they mention 20,800 entries are available. After that, how many columns are available? So here mention total 5 columns are available. So these are the list of the columns: ID, title, author, text, and label. And these are the data types for each of the column. For example, if you see in the ID column, there are numbers are there, numeric data is available. So here ID column, the data type is mentioned in 64. Same if we see for the title column, the data type is object. Object means what? So here basically the text data is available or string is available. If you see in our data set, for the title, text data is available. And one more information we receive from by using this info function. If you see here, non-null count is available. So our in our data set, 20,800 entries are available. If you see for the author, 18,843 entries are available. So means what? Here some rows are having missing values. So we need to handle those missing values also. So I will add here one row, data analysis. So once we read the data, so our first step is we check the target columns. So our target column is label column. See if we check df of label. So we check here how the data is distributed here. So one is available 10,413 and 0 is available 10,387. So if we see, both the data is having equally distributed, but sometimes what happen, the data is not equally distributed. For example, for the one, the data is having like 10,413, but for this 0 is having around 5,000 something. So in that case, what happened? Data imbalance is happen. So imbalanced data set means what? Where the target class has an uneven distribution of the observation. Means one class label has very high numbers of observation and the other has very low number of observation. To handle this, we have the some techniques also: undersampling, oversampling, and the smooth techniques. But in our data set is equally distributed, so we do not require to go with the steps. So our next step is we check the shape of the data. So we just type df.shape, and once we execute this, we will get the shape. Like shape is nothing but these are the row and these are the columns. Now we know the author having some missing values. To check those missing value, we use isNA function. So data frame dot isNA dot sum. By using this function, we will get the missing values rows count for each of the columns. So if you see here, the ID column having 0 missing values, but for the title, author and text, there are having some missing values. For the title, it's a 558, author it's a 1957, and for text it's a 39. So if we have the numeric features or column, in that case we replace those missing values with the mean, median, mode. But if we have the categorical feature like yes, no, true, false, so in that case we replace with the mode values. But in our case, whenever we working on the NLP dataset, so most of the time the text data is available. So here we cannot replace with the mode or anything. So in that case we need to drop those columns. By to drop those columns, we require one function, drop any function we require. So here I'm use df dot drop any function. Once you execute this, now we drop the missing values rows. Okay. Again, if we execute this command, df dot isNA dot sum. Now if you see here, missing value count for all the columns are 0. Means what? We handle the missing values. After that, again, if we check the shape of the data, now our shape will be changed. Means what? Initially, we have 20,800 rows. Once we handle the missing values or remove those missing values rows, after that, our data becomes 18,285 rows. Now here, we reset the index, df dot reset underscore index in place is equal to true. Again, if we check df dot head, index will be reset here. Okay. Now here, if you see, there are columns like ID, title, author, text, and label. So here we work only on the title columns. So we require only the title column and the label column here. Okay. So remaining columns will be dropped here. Okay. So actually what happened, if we see in the text, if we see in the text, in the huge quantity, the data is available in the text. Okay. And if we see the same for the title, only heading is available for those particular news. So for the time constant, we work only on the title dataset. If we work on the text, so it will take too much time for the data pre-processing and other operations. So for the time constant, we only work on the title features. So we need to drop those columns. So there is a one function is there to dropping those columns. df dot drop. Here we need to pass the column which you need to drop. So first is ID, After that, second one is a text. After that, third one is author. And here we mention the access. Access is one is nothing but columns. And access 0 means rows. If we check now again df.head, now our data set is created with title and label. Now we move to data preprocessing. So in the data preprocessing, basically we perform few steps like the tokenization, make lowercase, remove stop words, stemming, and the lemmatization. So data preprocessing involve the preparing and cleaning the test data for machines to able to analyze it. Preprocessing put data in workable form and highlights feature in the text that an algorithm can work with. So first of all, I will explain one by one all the concept like what is tokenization, what is stop words, what is stemming and lemmatization with the examples. And after that, we same procedure or same operation we perform on our final data set. So first is the tokenization. So I will take one sample data. The quick brown fox jumps over the lazy dog. So this is our sample data. So first of all, tokenization means what? The word there is a two tokens like the word tokenization and the sentence tokenization. So here we see the word tokenization. So word tokenization is used to break the sentence into the separate words or tokens, or we can say is the process of splitting a string into a text or list of tokens. So basically, first of all, understand why the token is required. So basically, the token helps in understanding the context. Also, they can help interpreting the meaning of the text by analyzing the sequence of words. Okay. So here, basically, we can use the one simple thing also. Simple underscore data dot split function we can use here. Okay. So basically, whenever we have the string data set, and if you want to convert those string data set into the list of words, say in that string function, there is one function is available, string dot split. So our string will be stored here in the sample underscore data. So we just call this sample underscore data object dot split function we use. So once you execute, if you see here, our data which is available in the sentence is now converted into the list of words, or we can say tokens are created here. Second operation is make lowercase. So why this operation is required basically? So if you see in this sample data set, okay, the is present in the two times. One, the start with the capital T, and the another the start with the small t. So what happen if we go for the next pre-processing, when we convert our text data in the numeric? So what happen? Two different feature is created. The word is same, but what happen? Here the capital T is used, and here the small t is used. So that's why two separate feature is created. One feature is created with this the, and second feature is created when this the. Or sometimes what happen in our data set, some typo mistake is there, like like this type of data is there. Okay, so if we see all three words are same, but they can represent like this. First one is represent with the capital T, second is represent with all the letters or small letter. Here the H is represent with the capital H. So here what happened, three different feature is created. To avoid this type of thing, we convert all our data into the lowercase. So we here basically we use a list comprehension techniques. So we use for data in sample data, and we perform a string dot lower operation. So on this data we use data dot lower. So this lower function is available in the string, and save this as a sample data. Now if we execute this, okay, now if we see the initially the this the is start with the capital T, but once we perform this operation lowercase, all our data is converted into the lowercase. Now third operation is remove the stopwords. So in English, there are a lot of words that appear very frequently, like is, and, the, but NLP pipeline will flag these words as a stop words. So stop words are those words in the text which does not add any meaning to the sentence, and, and their removal will not affect our pre-processing of the text. So why basically remove the stop word? They are removed from the vocabulary to reduce the noise and also to reduce the dimension of the feature set. So we create one stopwords object. Okay, initially we import one library is here. From nltk.corpus import stopwords. Same, we copy this function, and we call here stopwords dot words, and here we pass English. Here we need to pass the language. So I just print 10 stopwords. Okay, and also print the length of the stopwords. Once you execute this, now you will see. So total stopwords are around 179. Out of this 179, I just print the first 10 stopwords. I, me, myself, me, we, our, you. Okay, so these are the stopwords. Okay, so again we take same data set. Here also we use some list comprehension. So again for data, for data in stops in the sample data. Okay, if not in stopwords, if the is not available in the stopwords, then print those data. Again here we create one object sample data. Print for sample data. We check the length of the sample data. For data in sample data, if not in if data, not in Stopwords and print this. Okay, so if we see initially there are total 9 words are there. Okay, after removing the stopwords, the length of our sample data is 6. So what happened? So here basically we remove the stopwords. So if we see in our data original, the is available initially, but after removing the stopword, the will be removed because we already saw the is a stopwords. Again, quick as it is, brown cut as it is, fox, jumps, over is also the stopword. So over is not available here. Same, the again the is removed here. So the is also not available here. So this operation is called as a remove the stopwords. After that, we move to the fourth operation, which is called as a stemming. So stemming is used to normalize the words into its base form or root form. The big problem with stemming is that sometimes it produces the root word which may not have any meaning. So either when we doing the data pre-processing, either we go with the stemming or either we go with the lemmatization. So the major difference between these two, the lemmatization basically is quite similar to the stemming, but it is used to group different inflected form of the words. It's called as a lemma. The main difference between stemming and the lemmatization is that it produces the root word which has a meaning. But if we compare the speed, in that case, stemming is faster than the lemmatization because in the lemmatization, scan a corpus which consumes time and the pre-processing. So in the interview also they can ask you like most of the time like what is the difference between stemming and lemmatization and which one is the better. So we can say here like based on the application we should decide. Okay, if the speed is focused then we go with the stemming, and if the our application is a building language application, in that case we go with the lemmatization. So first of all we will see stemming. What happened with the stemming? So for the stemming also we create one object. Okay, for stemming and the lemmatization we import one libraries from nltk.stem, import porter stemmer and wordnet lemmatization. So porter stemmer is used for the stemming object and wordnet lematizer is used for the creating the lemmatization object. So first of all we create the object for the stemming. So here I created a ps object. Okay, and I just use sample data stemming. Okay, here also again we use list comprehension for data in sample data. Here we use those object, this object ps dot stem, and here we pass our data. Now we print sample data stemming. So this is our stemming output. Okay, now we see the lemmatization operation, so you will get the difference. So here also we need to create word lematizer object. LM is equal to wordnet lematizer. Here also I will create sample data underscore lemma equal to, here also we use list comprehension for data sample data. Here also we use lemmatization object lm dot lemmatize, and here also again we pass the data. Okay, so only the difference is here we use a lemmatize, okay, and here we use the stem. Now we print sample data after lemmatization. Okay, so this is our stemming output, this is our lemmatization output. So what is the difference between these two? They told like here we will get meaningful word in the lemmatization, whereas in the stemming we will not get the meaningful words. If we see, all words are same, but if you see for the lazy, okay, so here the meaning is changed for this word. That's why most of the time the lemmatization is used when we building any language application. Okay, and if you want like the speed is important, so in that case we go for the stemming. So these are the 5 operations we perform while doing the data pre-processing. First is a tokenization, second is a lowercase, third one is a stop words removing, fourth one is a stemming or lemmatization we will go. Okay, so this all the operation we perform on our main data set, which is created with title and the label column. So now I will create first lemmatization object, and here I will just create one empty list. Okay, so here I initialize the empty list with the corpus object. So for here we use a for loop for I in range. Here we pass length of data frame. So if we see our length of our data set, it's around 18,285. So means what? Our for loop executed 18,285 times. So here we use a regular expression re dot sub. We work on only the title column here. So in the for loop also we pass here the title column. Okay, and we mention the I means what? Our in the initially the I value will be the 0. So they access df of title of I. So df of title of I means df of title of I is nothing but initially is a 0. So initially the first row they access. Like same if we go to the 1, the second row will be accessed. So one by one all 18,825 rows will be accessed by using the for loop. Now use a lowercase operation here. After that, once all the data in the lowercase, then split operation is there, like the tokenization. So list of here, basically in the split operation, we convert our string into the list of tokens. So review dot split. Now apply here we lemmatization operation. So here again, for each character in review, if x not in, we already created this stopwords object, not in stopwords, or we can again write like stopwords dot words of English. Then you can use lemmatization on that. Close this with a square bracket. Now review equal to, so once the lemmatization is applied, now we again join this sentence. Append the final output in this corpus list, corpus dot append. Now we execute this. Or x in review if x not in, just pass stopwords. If we check length of corpus, it's around 8 to 85. Means what? Our pre-processing is done. Okay. So if we see the difference, okay. So DF of title of 0. So this is our original text. Okay. And after pre-processing, we get this output. Okay. So if we see here, all the characters are converted into the lowercase. Okay. Also here v is available and here v is remove, means what? V is nothing but this is our stopwords. So after pre-processing, we drop those stopwords also. So this is our output out of data pre-processing. Till now we completed till data pre-processing. So we done till this here, till the data pre-processing. Our next step is vectorization. Here we convert our text data into the vector. So we have the two options here: bag of words, which is called as a CountVectorizer, and second option is a TF-IDF, term frequency invalid document frequency. So in our project we work on TF-IDF operations to convert our text into the vectors. So for that we import one libraries from sklearn.featureExtraction.text import TF-IDF vectorizer. So here, first of all, we create object for the TF-IDF vectorizer. Okay. So once the object is created, then we can create x is equal to, okay, ef dot fit underscore transform we need to use. And here we pass those corpus. Corpus is nothing but our data preprocessing output. And this output we converted into the array. So once we execute this, we convert here our text data into the vectors. So same, we create one y label as well. So here basically x label we created. Same, we created the y label. So y is nothing but our dependent variable. So dependent variable means our target variable. So if we see in our data set here, target column is a label. So here 1 and 0 is mentioned. So what we do, df of label store in the y. See, if we print this y dot head, so 1 and 0 are available. Okay. So our next step is split data into the train and test. For that we require one libraries, train test split function we require. So from sklearn here, from sklearn dot model selection import train test split. I just copy this train test split. Okay. And we need to pass x and y. So x is nothing but this and y is nothing but our output. So we pass first x and y parameter. After that, here there is one parameter is test size. So test size is nothing but about how many data is required on the testing and how many data is required on the training. So here we consider 0.3. So 0.3 is nothing but 30% data we use here for the testing and the remaining 70 data we use for the training. Random state is equal to 10. So why we use this random state parameter? So what happen? Every time we get the same data, that's why we require to mention the random state. You can mention any value for that. And one more is parameter is stratify. This parameter we use because we require equal amount of parameters. Like the, if you see in the target column, 1 and 0 is available. So whenever we train or test the data, so we require equal amount of observations for 1 and from 0. Once this is done, then we can mention here x train, x test, y train, and y test. Once we execute this, okay, now we check the length of our x train and length of our y train. Okay, so if we see the both are equal, x train means our independence variables and ytrain is our dependent variable, or we can say this is our input and this is our output. Again we check the same for the length, x test and y test. Okay, these are also equal. Now we move to the next step. It's a model building. So here also we require random forest classifier object we need to create first. So for that, here from sklearn.ensemble we import a random forest classifier. So in the sklearn there is multiple algorithms are there, like the logistic regression is there, decision tree is there. All those algorithms we need to call by using this sklearn library. So currently we require the random forest classifier. That's why we mention here sklearn.ensemble. But if you want a decision tree classifier, so in that case sklearn.tree will be used. And if you want the logistic regression, so instead of sklearn.ensemble, write sklearn.linear model, and in that linear model logistic regression algorithm will be there. Okay, so currently we require random forest classifier, so that's why we import this library from sklearn.ensemble import random forest classifier. So first of all, we initiate our random forest classifier object, give the variable like rf. Okay. So once we initialize this random forest classifier object, then we need to feed training data. So here our training data is xtrain and ytrain. So here we can say we train our model. Once we execute this, it will take some time. Now our model is trained here. Okay. So model for the model training they take around 5 to 6 minutes they take. Okay. So once the model is done, then we can go for the model evaluation. For the model evaluation, first of all, we need to predict X-based data. So here I create one variable y predict and we use our model. So model is nothing but our RF is our model, RF dot predict, and here we pass X-based data. Okay. So based on that we will get the y prediction. So here we just use accuracy score. Here we calculate the accuracy score. So if you go again above, so if you see here for the evaluation we import these three functions from sklearn.matrix, import accuracy score, confusion matrix and classification report. So first of all we check this accuracy score. See here, first of all we need to pass y test and y prediction, this one. Okay, so if we check this accuracy score, so we receive around 93% accuracy. So what we do now, we will create one evaluation class to checking the accuracy on training dataset as well as on the testing dataset. I will tell you how to create a class and how to define method in that class. So first of all, we mention class evaluation. Okay, so whenever we call this class, okay, so here we mention one method, init method we call, and here we pass self comma model comma extract xtest ytrain and ytest. Okay, so here we define some variables. Okay, so first of all, self dot model is equal to model self dot extract is equal to extract self dot xtest is equal to xtest self dot ytrain is equal to ytrain self dot ytest is equal to ytest. So whenever we call this class evaluation class, we need to pass these things: models, xtrain, xtest, ytrain, and ytest. Okay. Now here, whenever we check the accuracy, okay, we need to check two things. We need to check the training accuracy as well as the testing data accuracy. So first of all, we create a method for to test the training data accuracy. df train underscore evaluation. Here we pass one self method. Okay, and here we create y prediction underscore 10. So the same thing we create here also, we create a y prediction. Okay, the same thing we create here also, y prediction. We check on the train data set. That's why I mentioned here underscore train. Okay, and here we take self dot model. We already define this thing in the init method, so we call this variable in this method self dot model, okay, dot predict, and here we pass self dot x train. Okay, here we check the prediction on the x train dataset, training dataset. If we the same, if we require on the testing dataset, so instead of the x train we pass here the x test. Okay, now, okay, here also we pass the same rf is nothing but our model dot predict x test. So here also we doing the same thing for the training self dot model dot predict. Okay, and here we pass the x train. Now we check here accuracy on training accuracy score. Okay, here we pass self dot ytrain and this prediction. Now in here accuracy score on training dataset. Okay, and we pass this result here. Okay, now we check the same for the confusion matrix as well as for the classification report. The confusion matrix, okay, on training dataset. Okay, okay, here also we pass the same thing, y train and prediction. Here also I just copy this line again. confusion matrix on training dataset. Okay, I just copy the same line for the classification report as well. Instead of confusion matrix, we call now classification report. Okay. So same method we create for the testing data as well. So whenever we call this class along with this method, okay, so we will get accuracy score, confusion matrix, and classification report as well. Now we create same for the testing data set. Instead of training, we may change here to test. Okay, by prediction on test data set. Okay, self model dot predicts instead of extend, we pass here x test now. Okay, here also accuracy score instead of y train, we use here y test. Okay, and this parameter y prediction test we pass here. So same thing we need to do for confusion matrix as well as classification report. Okay, so we create this class for the evaluation. Okay, so what we do, first of all, we create a init method. So in that init method, we pass the parameter like self model xtrain, xtest, ytrain, and ytest. We create a variable for that model xtrain, xtest, ytrain, and ytest. After that, we define one method which is called as a train underscore evaluation to checking the training data accuracy. So here we create one variable y prediction underscore train. Okay, whatever the model we use, for example here we use random forest, so random forest model dot predict, and here we pass extrain data set, and based on that we check the accuracy score, confusion matrix, and classification report. So whenever we check the accuracy score, we pass two things. First is a y train. Okay, this is our actual output, and this is our predicted output. So we compare the actual as well as the predicted output, and based on that we will get the accuracy score. Okay, same we create for the test data set. So instead of extract, here we pass the x test and remaining thing as it is. Okay, so we execute this class. Okay, so first of all what we do here, checking the accuracy on training data set. Okay, so we require this class, so I just call this class. Okay, evaluation class I just call. So whenever this class is called, okay, what are the things we require? Five things is required. Model we need to pass xtrain, xtest, ytrain, ytest. Okay, so model is nothing but our this rf. We already create a model build, model train. So rf is nothing but our model name. Okay, and xtrain, xtest, ytrain, ytest is nothing but this thing. We already split our data into these four things: xtrain, xtest, ytrain, and ytest. So we just pass here one by one. Okay, so first of all we create our class object. Okay, so here once the class is created, once the class object is called, okay, along with we call this train evaluation method. So just dot here after the dot, call this method train underscore evaluation. Okay, if we execute this, okay, if we execute this, okay, so here basically training data set accuracy. So accuracy on the training data set is 1.0, means 100% accuracy we receive. This is our confusion matrix. So confusion matrix basically is a invariant matrix used for the evaluating the performance of the classification model. So basically this will be give the holistic view basically, okay, how well our classification model is performing and what kind of error is making we will get here. Okay, so if we see, this is our false positive and false negative error. Okay, but here both the error are 0. Okay, that's why we get the 100% accuracy. After that, we get the classification report as well. Okay, so what we do here, we add one printf statement, blank print statement. One line, so one line will be added in between. Okay, again we execute this, again we execute this. Now you can easily understand. Okay, one line is added in between this. Okay, now this one is the classification report. So on the classification report we will get precision, recall and F1 score value. Okay, same we check for checking, same for the testing data set. So we just here call checking the accuracy on testing data set. Okay, here also we same. First of all, we need to call this class evaluation. Okay, so in that we need to pass 4 to 5 parameters. First is a model. So model is our random forest, this model. We pass first random forest. Okay, after that we need to pass x train, y train, x test, y test. Okay, once this class object is created, okay, now we call test evaluation method. Okay, here we define the test evaluation method. We just call this here. Okay, once you execute this,
We receive accuracy on testing dataset.
okay, in here we need to change instead of training, testing everywhere. Okay, so here
We received the accuracy on testing dataset is 0.93, means 93%. Same we got here also. Before creating the class, we check the accuracy.
here if we see, there are some errors are there, 284 and this 53. Okay, so out of around 6,000 observation, few of the observation, it's around 350 observation is wrongly predicted, but the remaining one is correctly predicted. That's why our accuracy is around 93% accuracy. Okay, now what we do, one more thing. Okay, we create one pipeline. Okay, when we receive the any data from the users, okay, new data from the users or from the client, how our model will be worked. So we create a one prediction pipeline here. Okay, I just mentioned here prediction. Okay, so till now we completed this section, model evaluation. Okay, I already told we do not perform this model deployment. Okay, we directly jump to the prediction on the client data set. So what we do, we create a one complete pipeline. Okay, so once we receive the data from the user, so our first step is data pre-processing. After that, convert those data into the text.
After that, predict output with the help of train model. All these things we created here.
So first of all, we create one class which is called as a pre-processing. Okay, so here basically we mention again d underscore underscore init. You need to pass here the self keyword. Okay, and one more thing is data. Okay, here self dot data variable is created is equal to data. Okay, now we already created text pre-processing. Okay, so we just copy from this. Okay, so I copy this. Now we create here DA text pre-processing. Okay, underscore I mention here the user because we received this data from the user. That's why I mention here text pre-processing underscore users, and here we mention the self keyword. Okay. Okay, here only we need to change some of the code. Okay, what happened here initially, we work on the complete data set. Okay, that's why we here mention for I in range of length of data frame. Okay, but here we currently now we work on only the user data user inputs. Okay, so here we create one thing. Okay, prediction data. So we need to predict on our user data set. Okay, so user data. So whenever we call this pre-processing class, or we need to create the object for this pre-processing class, we need to pass the data as well. Okay, so those data store into this prediction underscore data. Okay, so here now what we do, instead of corpus we give the name like pre-processed data. So pre-processed data will be stored here. Okay, so for here we just change for data in, instead of the len, now we just pass this pre-processed data. Okay, here also we pass the data only. Lowercase split lm dot lemmatization stopwords review dot time purpose. Okay, and this function return pre-process data. Okay, so what we do, we try to execute this function first. Okay, this is working or not. Okay, so I just take one data. Okay, like same like df of title of 0, instead of 0 we get 1. So I just copy the same data. Okay, data is equal to same text I have copied and pasted here. Okay, so on that we need to pre-process this data. Okay, so first of all we need to call this pre-processing. So whenever we call this pre-processing, we need to pass the data, because here in the init we mentioned the data. So data is nothing but our this data. Okay, which is received from the users. Okay, in that we need to call this text pre-processing from users. Okay, once you execute this, okay, see, if you see here, we will get this pre-processed data. Okay, so here also first this text is converted into the lowercase, and somewhere here on is available in the original data, but here we remove here with the help of pre-processing. Okay, so this class is executed correctly. Okay, now what we do, we create one more class which is called as a prediction class. Okay, so class prediction we created. So whenever we create a class, okay, so class object always start with the capital letter. Okay, here also we define underscore underscore in it, underscore underscore, okay, self, and prediction data we pass here. So I just create one object, self dot prediction underscore data is equal to prediction underscore data. Okay, and here I define one class, prediction class we define prediction, okay, underscore model, and here we pass the self. Okay, so first of all we call the same function, okay, pre-processing underscore data, okay, text underscore processing dot user here. Okay, same thing we call here, and we give the one name pre-process data, pre-process underscore data. Okay, so this variable is we call, and here we once we receive the data from the user, first of all we pre-process those data. Okay, so here we define the prediction data is equal to self underscore prediction data, so same variable we pass here. Okay, so once our data is pre-processed, then what is our next step, we convert those data into the numeric or vectors. Okay, so initially when we create this TF-IDF, when we converted this text into the vectors, so first of all we call this TF-IDF vectorizer object, and here we use TF-IDF object dot fit underscore transform we use. Okay, so here when we receive the data from the user, instead of fit underscore transform we just use transform method. Okay, and here we pass data, pre-processed data. Okay, so this pre-processed data I have passed here. So what happened, so by with the help of this TF-IDF we convert our data into the numeric. Okay, and then we make prediction. Okay, so prediction is equal to, so what we do, prediction is equal to model dot prediction. Okay, so our model, so here what we do, I just pass one more parameter like a model. Okay, and here just pass self dot model, okay, is equal to model. Okay, and the same thing I am mentioning here, self dot model, okay, dot predict. Okay, and here we pass those data, this data I just passed here. Okay, so now what if our prediction, okay, if our prediction of 0, okay, if double equal to 0, then return the news is fake. Okay, else return the news is real. Now I execute this. Okay, so what we do, we create this, let's assume this is our user input. Okay, so if we see what is our input, okay, the same input we saw here in our data set. Okay, this one is the same. Okay, so what if, let's consider this is our user data set, user input. Okay, so on this user input, okay, what is our prediction is 0. Okay, so 0 is nothing but what we define here, the news is fake. Okay, so our we require output like the news is fake. Okay, we just check our model is predicted correctly or not. Okay, so let's consider this is our user data. Okay, and we just call this class. Okay, this class we need to predict. Okay, so in that class we already define this class also. Okay, so if we see here in the pre-processing, okay, dot self dot predict, and here we mention text pre-processing underscore user. So this class we already called here in this prediction. Okay, so once our data is pre-processing, then we can convert it to the vectors, and after that we predict here the prediction. Okay, so whenever we call this class, okay, prediction, we require two things. Okay, first in the data, prediction data. So prediction data is nothing but our this user input. Okay, and second thing is require the model. So we already create a model. What is our model? Rf, this model. So we pass here Rf. Okay, once you execute this, we will get either the news is fake or we will get either the news is real. Okay, once we execute, mm, just a moment. Okay, so we need to call, okay, I forget to call this prediction underscore model. So dot prediction underscore model. So basically what happened here now, so our class object is created. Okay, so once the calls, this is our, till this we create a class object, and after that we call this method. So under this prediction dot method, our output is generated. So once you call this method, we will get the output like the news is fake. Okay, same when the news is fake, if the prediction is 0. If the prediction is not 0, then we will get that the news is real. Okay, so here example for the fake news. Okay, same we check for the real news, is predicted as correct or not. Okay, if we see in the third, okay, 15 civilians killed in the single US. Okay, we take this example. If we see for this, the prediction is 1. Okay, so first of all I just written, okay, 3. Okay, so we will get this news. Okay, again we use data unique. Okay, or user data, we can say here, user underscore data is equal to, okay, now again we call the same thing. Okay, instead of this data we just use user data here. Okay, now what is our expected output? The news is real.
Okay, so expected output we receive here. So our fake news classification with the help of natural language processing project is done. Same project I have uploaded on GitHub. You can find the GitHub link in the below description. Thank you for watching this video. If you like this video, please like, share and subscribe my channel. Very soon we will upload few more videos related to machine learning and NLP projects. Thank you.